Welcome to the demonstration of our Cyberbullying text analyzer. Before we start, I want to mention that this program is specifically optimized for the Windows operating system. We use the Windows API to create a better user interface with colors and to handle file directories robustly, so it runs best in a Windows environment. And let me briefly explain the architecture. We chose a modular programming approach, separating the code into header files and distinct source files, like file processing, sorting, and tokenization. As you can see, we designed a colorful dashboard menu to make it user-friendly. Let's start with data loading. We implemented a feature that detects .csv files and treats them differently from txt files. Standard file reading functions like fscanf stop at spaces, which is unsuitable for reading sentences. We chose to use fgets combined with a custom state machine parser. The justification for this technique is that CSV files often contain commas inside quotes. A simple star-talk split would corrupt the data. Our custom parser checks for quote status to ensure we extract the column correctly. Now, let's push the system to its limits. We will load the train.csv dataset from Kaggle, which is over 50 megabytes. Notice that it automatically switches to distinction mode to parse the CSV format. Also, look at this warning. We implemented a memory safety limit at 100,000 words. This is intentional. It prevents the program from crashing due to memory overflow while processing massive real-world data. Now we select option 2. The program calls the show word statistics function and displays the statistics on screen. Total words processed, unique words stored, total sentences, average sentence length, and lexical diversity. Now we proceed to option 3, analyze toxic words. The program will rescan the loaded file and compare it against the dictionary that was loaded during initialization. It identifies any offensive words or phrases present in the text. As you can see on the screen, the analysis shows the first 15 lines for a quick review. For example, in line 2, the word ugly has been detected. The system displays its severity level and highlights it in bright red for immediate attention. Now we select option 4, sort words by frequency. The program first checks if word data has been loaded. If data is available, it calls the sort words by frequency function. Its job is to take the word list in memory, which is in a random order, and rearrange it based on how often each word appears, from most frequent to least. This step prepares the data for generating the top-N report, and may take a short moment to complete. This is the most important part regarding data sorting. Option 5 is a benchmark comparing bubble sort, quick sort, and merge sort. I included this benchmark to justify the algorithmic choice. While bubble sort is easy to implement, its higher time complexity makes it inefficient for large datasets. As the results clearly show, bubble sort takes over 100 seconds, whereas the advanced algorithms complete the task almost instantly. To enhance the user experience, we implemented option 6, display top N report. This option prompts the user to enter a number N. It then displays the top N most frequent words from the sorted list, alongside a separate report highlighting the most frequent toxic words found. Instead of just presenting a plain list, the program calls the Draw ASCII bar chart function. This generates a simple yet effective ASCII bar chart directly in the console, visualizing the frequency of each top word for immediate, intuitive understanding. To make this output clear and scannable, we utilized Windows API calls, specifically set console text attribute, to manipulate console text colors. The rationale is that raw textual data is difficult to parse quickly. By implementing color coding, using red for toxic words and green for clean, high-frequency terms, the program provides instant visual feedback. This significantly improves the human-computer interaction aspect of a standard console application, making data analysis more efficient. Now let's select option 7, Save Comprehensive Report. This is the program's most advanced feature. It pulls together all the analyzed data, statistics, top words, and toxic word findings, and performs final calculations like the toxicity percentage. Finally, let's view the report. Now, you may exit the program. This concludes the demonstration. Thank you for watching.